Okay, this is the P4 paper from June 2021. It's question number 9 and two-parter to this one. The first part is vectors and then the second part is proof by contradiction. So let's make a start. We've got quite a bit to do. Number 1 says, given that A, B and C are 3 points lying in a straight line, B is in between A and C. If the ratio of AB to AC is 1:3, can we show that C is equal to 3B minus 2A? So, what I would generally tend to do with these is just write a quick sketch because it might help me with my understanding. It doesn't always, but it is a very quick sketch, so it's not going to take me too long to actually do this. I've got the line ABC here then, and I want to do what they've said. They've said AB to AC is 1:3. So if I put A there, and I put B there, and I put C there, AB is compared to AC. That's 1:3. That's clumsy looking. Better to write it as 1 and 2 there to now say that AB is 1 compared to AC is 3 there. So make sure you get that right. It's a pretty standard looking thing to do, but just be careful about that bit there. So we've got that then, if that's the vector OA, and that's the vector OB, and that's the vector OC. Okay, right, so what am I going to do with this? What I would generally tend to quite often do with these vector sort of proof things is try and get a vector written in 2 different ways. I'm going to choose to do AC. So if I'm going to do AC, we can see that AC, well, I would hope you would know it's C minus A, but let's just go slowly with it. AC is AO plus OC, so it's minus A plus C. It's C minus A, but as I say, I would have expected you to be able to do that already. And then AC is equal to that. Let's get AB. So AB then, following exactly the same idea, is AB is AO plus OB this time, which again is minus A plus B is B minus A. Why did I get AB? Because the one thing that they did tell me was that AB to AC is 1:3, and if AB to AC is 1:3, I can then say that AC is equal to 3 lots of AB. So that's equal to 3 lots of B minus A, which is 3B minus 3A. And now these two are going to be the same as each other. Put the arrow in there. These two are going to be the same as each other. So we can now just say C minus A is equal to 3B minus 3A. Oh, just fall straight out then. Okay, so C is equal to 3B minus 2A, and that's actually what we wanted to prove in the first instance. Okay, so that's part 1 done. Part 2 is this proof by contradiction. So one of the things that we've got to do, if we're trying to do it, is think about what the statement that we're going to make my assumption is. With proof by contradiction, what I'm going to do is I'm going to make an assumption and then prove that my assumption is wrong. So given that this situation is what we've got here, if n squared is a multiple of 3, then n is a multiple of 3. I'm going to try and do that. So I'm going to say, okay, for part 2, I'm going to make an assumption, assume there does exist a number n, there exists a number n which is not a multiple of 3. Okay, I want the opposites of the statement that we're trying to prove is not a multiple of 3. If I do have that situation, I'm going to say n squared, n squared, oh, let's just type it up, and n squared is a multiple of 3. So I'm going to make that assumption and then try and prove it, and it won't work when I try to prove it. So if n is not a multiple of 3, n can be what? Well, n can be if you think about the way I want to set this out, 3k, 3k plus 1, 3k plus 2, 3k plus 3. If I consider those consecutive numbers, that's a multiple of 3, then that isn't, and then that's a multiple of 3. So the two non-multiples of 3 are 3k plus 1 and 3k plus 2. So I'm going to do it for those two. I'm not leaving that in my answer, that's just explaining it to you guys. So if n is equal to 3k plus 1, not a multiple of 3, making it clear. What happens if I do n squared? Well, n squared is equal to 3k plus 1 squared, which is, that's 9k squared plus 6k plus 1. Well, if I take 3 as a factor out that first bit, I'm now writing that down as 3p plus 1, not a multiple of 3. So that's the first bit that doesn't work out. Let's try it with n equals 3k plus 2. Again, not a multiple of 3. So we need this to work out to be a multiple of 3 when I square it. We know it won't, but n is equal to 3k plus 2 squared, which is 9k squared plus 12k plus 4. I'm just doing 3k plus 2 times 3k plus 2 quickly in my head because I can do those. If you want to multiply it all out a little bit slower, it's still going to come to that. So, take your time if you need to. Right, what does that work out to be? Well, the quickest way of doing it is to say this, it's just seeing this. This is 9k squared plus 12k. I'm going to split that 4 up into 3 and 1. Why? Because I want to have all this bit being a multiple of 3, so I can get 3p plus 1 again. Okay, so if you've done enough of these proofs, you'll have seen that a few times around. That's 3k squared plus 4k plus 1 plus p. Doesn't matter what's in the bracket, that's 3p plus 1, which again is not a multiple of 3. So I've tried to assume something, and I've now shown that my assumption doesn't work. So I'm now saying, therefore, my assumption is wrong. And if my assumption is wrong, I can then go back to the original thing. So go back and see wherever it is. See the language up there, and we're going to say, therefore, if n squared is a multiple of 3, then n has to be a multiple. Then n is a multiple of 3. Excuse the handwriting, but what we did with that was we looked at the statement, we made the opposite assumption, we went all the way through so that the opposite assumption fails at some stage. Once it fails, then we can say, right, my original statement was true. Proof by contradiction. Hopefully that all makes sense.